Hello everyone and welcome to the channel. Have you ever wondered how Instagram remembers exactly which photos you liked? How Amazon remembers your past orders from 5 years ago? Or how Netflix knows exactly where you paused your movie? The answer isn't magic. It's a database. But here's the catch. The way a bank stores your money is very different from how a video game stores your inventory. Today, I'm going to teach you about the database built for the modern, messy, fast-paced internet. It's called MongoDB. To understand why MongoDB is special, we have to look at the old way. In a traditional SQL database, you have to build a strict table before you can save any data. Imagine you are building a role-playing game. You create a table for your characters with 3 specific columns: name, weapon, and shield. First, a knight joins the game. Name, Arthur, weapon, sword, shield, iron shield. Perfect. Everything fits in its box. But then a wizard joins. He doesn't have a shield. He has a magic potion. Here is the problem. You can't put a potion in the shield column. The database says no, that is the wrong type of data. So to make it work, you have to leave the shield column empty, which is wasted space, and you have to create a brand new column just for the potion. Suddenly, your neat table is full of empty holes. It's messy, it's rigid, and it's hard to change. MongoDB solves this by getting rid of the columns entirely. Instead of a strict table, imagine every character has their own backpack. This is what we call a document. When the knight saves his game, he opens his backpack and throws in a sword, a shield, and that's it. When the wizard saves his game, he throws in a magic staff, a potion, and a spell book. See the difference? The wizard's backpack doesn't need a shield spot. The knight's backpack doesn't need a potion spot. MongoDB lets every single character carry exactly what they need, and nothing they don't. You don't have to design a complicated table. You just save the data as it is. Now, let's look at the structure. MongoDB is organized like a giant library. There are 3 layers you need to remember: database, collection, and document. First, you have the database. Think of this as the library building itself. This is the container that holds absolutely everything. If you were building an app for a school, your database is the whole school library. Inside the library, you don't just throw books on the floor. You organize them onto bookshelves based on their genre. In MongoDB, we call these shelves collections. You have one shelf, collection, for science fiction. You have another shelf, collection, for history. A collection is just a group of similar things. You wouldn't put a history book on the sci-fi shelf, right? You keep them organized in their own groups. Finally, on the shelf, you have the book. In MongoDB, this is the document. The book contains the actual story, the data. One book is Harry Potter. The next book is The Hobbit. Each book is unique, but they both live on the fiction shelf. So the hierarchy is simple. Database, the library, holds the collections. Collection, the shelf, holds the documents. Document, the book, holds the data, JSON. You create a database, you organize your data into collections, and you save your information as documents. That's it. So we have our book, the document. But how does MongoDB actually write the data inside? If you open this book, you won't see paragraphs of text. Instead, you see keys and values. Think of it like a label. Title, Harry Potter. Author, J.K. Rowling. Published year, 1997. It looks like code, but it is actually just a list of labels. On the left, you have the key or the label. In this case, title. On the right, you have the value or the data, Harry Potter. It's just a matching game. Key, author, value, J.K. Rowling. Key, published year, value, 1997. But here is the cool part. MongoDB can store more than just simple text. It can store lists. In the library, a book might belong to multiple categories. In MongoDB, we write that like this. See those square brackets? That is a list. We call it an array. You can store a list of tags, a list of friends, or a list of comments, all inside this one single document. Now, here is a tiny technical secret. When you write this data, you write it as JSON because it is easy for humans to read. But when MongoDB saves it to the disk, it converts it into a binary format called bsign. You don't need to worry about bsign right now. Just know that it makes the database incredibly fast and allows it to store different types of data easily. So there are hundreds of databases out there. Why is MongoDB the one that everyone talks about? Why do companies like Uber, Google, and eBay use it? It comes down to three big reasons. First, and most importantly for you, it speaks your language. If you are learning web development, you are probably learning JavaScript or Node.js. MongoDB documents look exactly like JavaScript objects. This means you don't have to learn a weird, complicated language just to save data. You can use the same logic in your app and your database. It feels natural. Second, MongoDB is perfect for startups and agile teams. In the old SQL world, if you made a mistake in your database design, it was a nightmare to fix. You had to take the whole site offline to change the structure. With MongoDB, you can change your mind. Did you forget to add a profile picture field? Just add it now. Did you want to change age to birthday? Just do it. It allows you to move fast and break things without actually breaking your database.
Finally, scalability. Imagine your app goes viral. Suddenly, you have 1 million users. Traditional databases often crash under that pressure because they are designed to run on just one big computer. MongoDB was built for the modern internet. It is designed to be split across many computers easily. So whether you have 1 user or 100 million users, MongoDB can handle the traffic. In the next video, we are going to stop talking and start doing. I will walk you through installing MongoDB step by step, and we will write our very first database command together. Thanks for watching, keep coding, and I'll see you in the next one.